Hello traders, it's Evgeny here, and today we are kicking off a series about building our own software for analyzing trading strategies. In my last video about moving averages, I came to the conclusion that to have full freedom in trading we need our own tool. Now it's time to dive into the architecture of this software. We will break down how it's structured, why I choose Python, why we need a custom solution instead of ready-made platforms, and how it all comes together from the core to integration with MetaTrader 5. My goal is not only to show you how it's done, but also to deeply understand the structure myself, so that the software turns out flexible, clear and powerful. Let's get started. Let's start by understanding why I decided to build my own software instead of using ready-made solutions like TradingView, QuantConnect or MetaTrader in its pure form. Pre-built platforms are great for getting started, but they come with limitations. For example, they often dictate how your strategy should look and don't give you full control over every step. Want to integrate a complex machine learning model or test a hybrid strategy that combines indicators and neural networks? In most cases, you'll hit the ceiling of their capabilities. Tools like ChatGPT, for instance, can't access real-time market data streams or make decisions the way we need. What we want is a system where we set the rules, control every step and can adapt it to any task. That's why I choose the path of custom development, to gain complete freedom and transparency, allowing us to build exactly what we want. Now let's talk about the programming language. I choose Python, and there are several reasons for this. First, Python is a standard for data analysis and machine learning. It provides access to powerful libraries like pandas for data handling, NumPy for calculations, ta-lib for computing technical indicators, PyTorch and scikit-learn for machine learning models, and matplotlib and seaborn for visualizing results. Second, Python is simple and readable. We don't waste time on complex low-level tasks like memory management or writing wrappers for C++ libraries. Instead, we focus on what matters most: the logic of strategies, data processing and decision-making. And finally, Python is incredibly popular. This means that for any task, whether it's loading market quotes or optimizing parameters, we can find ready-made examples or libraries. For me, as a developer, it's the perfect choice for quickly prototyping, testing ideas and refining the software. So how will our system be structured? In simple terms, think of it as a tree with a root, trunk and branches. Or in plain language, at the heart of it all is the core. This is the brain of our software, responsible for receiving data, managing strategies, and making final trading decisions. The core isn't just a signal relay. It aggregates information from all components, processes it according to predefined rules, and decides whether to open a trade, close it, or wait. Every process flows through the core: data loading, message routing, order management, logging, and state preservation. It's like a conductor of an orchestra, ensuring everything works in harmony. For handling data, we will use two approaches. To keep things simple at the start, we'll begin with CSV files. This is a convenient format for testing strategies on historical data. For example, you can load a year's worth of euro-dollar quotes, run a strategy, and see how it performs without any extra hassle. But for real trading we need live market data, and that's where MetaTrader 5 comes in. We'll connect to it using ZeroMQ, a library for high-speed messaging. ZeroMQ will allow our Python software to receive quotes, events, and order statuses directly from MT5 in real time. What's more, we can also pull historical data through ZeroMQ, so in the future CSV files will serve only as a supplementary tool for debugging. Our goal is to create a system that seamlessly switches between testing on historical data and trading on the live market without changing the code. Now let's talk about how we will generate trading signals. For this, we have a system of strategy aggregators. An aggregator is an independent model that takes data, processes it, and outputs a signal buy, sell, or wait. Each aggregator operates on its own and doesn't know about the others. This gives us two major advantages. First, modularity. We can add or remove aggregators without breaking the system. Second, flexibility. We can combine different approaches, compare their performance, and build complex strategies. At the initial stage, I plan to implement a rule-based aggregator that works with technical indicators such as EMA, RSI, and MACD. For example, it can check whether a short EMA has crossed above long EMA or if RSI is above 60, and then issue a buy signal. Later, I will add aggregator for machine learning and optimization, so the system can automatically adapt to the market. The rule-based aggregator is built on a modular principle. Instead of writing long, tangled code, we assemble strategies from ready-made blocks, like a construction kit. For instance, one block calculates EMA, another handles RSI, and the third deals with MACD. We combine them with conditions. If EMA 10 is above EMA 50 and RSI is above 60, the signal is a buy. If MACD crosses below its signal line and RSI is below 30, it's a sell. This block lives in the indicators folder, while the logic for combining them is in the signal-py module. This approach simplifies development, reduces the chance of errors, and makes it easy to tweak parameters or add new indicators. To tie everything together, I'm using an integration bus. This is a software layer that handles communication between the core and the aggregators. The bus allows modules to work asynchronously and independently, and new components like additional aggregators or a graphical interface can be plugged in without modifying the core. In the future, I will add support for JSON and YAML for storing configuration. JSON is great for APIs and data exchange, while YAML is perfect for visually addition settings, especially if we decide to build a graphical interface, and I'm sure we will. For now, all parameters are set directly in Python code, but I am already laying the groundwork to allow logic changes without rewriting models in the future. Let's take a look at the project structure to make things clearer. At the root, we have a folder called Trading System. Inside it, there are several key directories. The core folder contains the heart of the system, core py for the main logic, order manager py for handling orders, and strategy factory py for creating strategies. The integration folder includes bus.py, which is our integration bus. The strategies folder is divided into three submodules: rule-based for indicator-based strategies, AI for fusion neural network, and ML for machine learning, but it's gonna be more in the future. Inside rule-based, you will find builder.py for assembling strategies, signals.py for generating signals, and an indicator folder with files like EMA.py, RSI.py, and MACD.py. There is also an optimizer folder for future optimization algorithms such as grid search or Bayesian optimization. Everything is controlled through main.py, and settings are stored in config.py. At this stage, we only have an architectural plan. The foundation we'll build upon. The code hasn't been written yet, but I already have a clear vision of how everything will work. In the next video, I will show the first prototype, a functioning core, a connected rule-based aggregator, and a simple strategy based on moving averages. We'll put it together, test it on CSV data, and see how the core processes the signals. This will be our first step toward real software. So what's next? We have big plans. We will add GPU support to speed up computations, integrate machine learning models, implement result visualization, and start testing on live code through ZeroMQ. Gradually, the system will become a universal platform that can be adapted to any market: Forex, crypto, stocks, and any strategy from indicator-based to AI-driven. It's going to be a long journey, but it's worth it. Thanks for watching. Subscribe to follow the development, and let me know in the comments what features you would add to this software. Got ideas for new indicators or optimization methods? share them and I will consider them for the future videos. See you in the market.